there have been very few days where I've been as excited about 3D printing as today. So, what is going on? Well, we have a couple of things. One is Firestorm Labs. So Firestorm Labs is a company that has raised over $12 million from Lockheed Martin Ventures and others. It's run by, the CTO is Ian Muceus, who previously had stints at Origin, later at Stratasys, working in the aerospace parts there. They want to put a drone factory in a shipping container. This is something that's been talked about a lot of times by a lot of different people. It's a very obvious thing to put a forward-operated container right near the battlefield and to make drones very, very quickly where they're needed and also iterate them. You can see a rendering of the container. It looks kind of very multi-jet fusion-y to me, actually, the colors and things, but we don't know if that's... maybe it's a different machine or something like that, but it looks a little bit, at least in that kind of area. So it's called an XL shipping container. They hope to produce a drone under 24 hours and be able to function off the grid. The drone that they have designed initially is a Tempest. They want one chipset to power it that has most of the functions in it, which of course would allow you to integrate that into lots of different versions of this drone, which seems like a very sensible idea. They have a takeoff weight of 25 kilos, a payload of 4.5 kilos, and they want a wingspan of 2 meters by 1.8 meter and a length of 1.8 meters. Now that's a considerable size object. I'm not entirely sure if they can do that exactly in 24 hours. But it would be a nice goal to have them have a kind of working drone with printing most of the body in that time frame eventually. They initially want to start trying to make 500 of these things a month in their own factory and then later on produce containers overseas. Now, this is, of course, logical. We've been talking about this in our drone war series for many months now, and I've been talking about this for many years. Over a decade, the idea of just producing drones iteratively, quickly, in a forward operating area. So, yeah, this is something that's going to happen, but these guys are actually going to make it happen. So that's going to be a big thing for all of us. The next thing, which is also huge news, is from DARPA. And DARPA is coming up with the Additive Manufacturing of Microelectronic Systems program, AMME. What they're doing now, DARPA has played a huge role in 3D printing, and they've done a lot of stuff we may not talk about maybe, and other stuff that we may not even realize that's been very, very key to our development. They've really looked at these things that are very, very difficult for us to do without their help, and they've really helped us in key moments. And this is going to be another one of those. They're looking at multi-material printing of high speed, in a high-speed fashion, making a sub-micron devices. So they want a 500 nanometer resolution microsystem that is not bigger than a 1-cent coin be printed in under 3 minutes. So, DARPA is nothing if not ambitious, of course. This is an insanely ambitious challenge at the moment. But they're looking towards volumetric 3D printing, which has already seen a ton of hype, and selective material synthesis. So the idea of combining materials at a certain moment in time through, microfluidics or light-based or whatever kind of thing, to essentially get either tunable, gradient, or new material combinations, or to actually make like a polymer in situ. So these are kind of like, selective material synthesis thing is a bit broad at the moment. A lot of different people are parking a lot of different technologies under it. But generally, it's the idea to be able to make a material at a particular moment in time. And that, of course, could, really lead to, one system being able to make a device that is, electro-optical device, or electromechanical, or a biomechanical device, stuff like that. So this is super future forward stuff that I think is really important. If you have any chance of being a part of this, I would run for this and go for this. If you have any kind of connection to these people, if any way, shape, or form you could be a part of this, you should try. The next thing is news from Aerosint. Now, Aerosint, of course, was acquired by Desktop Metal, and then it was sold to Schaeffler. Schaeffler is a giant company, which also has a really small machine tool division. And Aerosint first tried to integrate its machines into other people's machines. And now, of course, under Sheffer, the idea is to make their own device. But in October 2023, they sold an Aerosint machine. I'm not entirely sure what this is combined with. You could tell me what you think it looks like. But the idea is that this went to a spark plasma sintering company called California Nanotechnologies. So it's nice to know that Aerosint is living, is being developed, it's being continued, because it is a really exciting way for us to combine ceramics and metals. And I'm still really curious to see what Schaeffler will do with the Aerosint technology. If it's just about the patents, if it's about like, you know, some revolutionary thing they're doing, battery technology, or they're trying to make multi-material molds for tires, or what are they really trying to do? This seems like it's just a fulfillment of an order that was made before or something like that. Under the Aerosint name, but you know, it's good to see these guys still be out there, because I think it is a really exciting technology. The next thing is also exciting. It's probably the terrible name actually. It's from Sandia Labs, and it's called SWOMP. And SWOMP is the Selective Dual-Wavelength Olefin Metathesis 3D printing. So what they're doing here is, well, at first glance, if you look at the diagram, it looks a lot like any kind of like that polymerization technology. But they're doing dual wavelength here. So they're using both ultraviolet and blue light to make the material. The second wavelength, what it actually does is it prevents polymerization, inhibits polymerization at the part of the vat. So we have this peeling problem, right, which you may have noticed in your Frozen or your Formlabs printer, that every single time you irradiate the part, it hardens, and then you have to let it go from the screen. And then you have to clean the screen maybe even, and then reapply it. Now, other people have been trying to solve this with an oxygen layer or all sorts of different solutions. And these guys have solved it in a super elegant way, I think. We, of course, don't know if it works, but this is Sandia Labs, so they've got some super smart people, a lot of resources and things that other people don't have. And, you know, I trust them a lot more than a lot of other people when they say certain things. So this idea is that this second wavelength actually inhibits the formation of this peel, so then you can just in a continuous type of way, just similar to carbon clip and stuff, produce parts. Now, what I like about this is this may actually allow for a greater variety than other technologies, a greater variety of masses and a greater variety of geometries. So this could be mega exciting. Now, the other thing is they're using olefin materials. Now, olefins are wonderful in a sense because they have really great chemical resistance. They are very strong in a lot of cases. They're more real-world resistance than a lot of the other vat polymerization materials that we're making. In this case, they're using DCPD, which is disulfopentadiene or something like that, which, you know, I've looked at the MSDS for this, the safety data sheet, and it, well, it looks kind of hazardous, so be a little bit careful with this. Bad for your lungs and kidneys and things if you repeated exposure, so we need to be really careful with this stuff, so it's not a panacea. But if the system does work and is safe, then we have maybe a path to creating these olefin geometries, which could lead to, well, things that could be used in a kind of processing, things that could be used in really advanced kind of microfluidic systems, for example, good chemical resistance to mix all sorts of chemicals, see the DARPA thing, right? And also, it could be used, for example, a lot of synthetic rubbers, like neoprene-like materials, and that's always been a problem for us, to make these literally rubber-like compounds that really resist the real world. And that'd be a huge thing for us. So, you know, all in all, between the news of Firestorm Labs getting funded and putting drones in containers, the DARPA, you know, embarking this super ambitious AMME project, Aerosint being alive, and Sandia coming up with the SWOMP today is an absolutely marvelous day for 3D printing, and very, very exciting news for all of us, I think. My name is Joris Peels, and this was another edition of 3D Printing News Unpeeled.